So today we're working on exponential functions, and in this video we're going to talk about just the basics of the exponential equation, or the standard form of an exponential function, and then we're going to learn how to sketch graphs of exponential functions. Okay, so the standard form of an exponential function is it's going to be either f of x, which remember f of x means that it's a function, or it could be y, because remember f of x is the same thing as y, equals a times b to the x power. Okay, now the reason why exponential functions are called exponential, and it's in the name, is to be an exponential function, you're looking for the x, and the x has to be an exponent. Okay, so in other words, x has to be in the exponent spot. All right, so notice in this equation x is an exponent, and so that's the one thing you're going to look for to make sure that an equation is exponential, or a function is exponential. So x is an exponent. Okay, so that's actually what makes the equation exponential. Okay, now what are these other things? Well, I already talked about f of x could also be written as y, so make sure that you remember that. But then when you're looking at the equation, a and b are actually going to be numbers. Okay, so let's talk about what these numbers mean, because they will have a meaning in terms of exponential functions. Okay, so a, whatever that number is that's kind of in the front there, will be your y-intercept. So if like you're looking at a graph, this is where that would cross the y-axis. Okay, now if it's like a word problem, like a real life kind of problem, this is your starting point, or your initial value. It's however many there were to start with, or what it started with. It kind of depends on the problem as to how you describe it, but it's your initial value, what you start with. Okay, and now b, the number that has the x with it, that actually has a name. Okay, and we're going to start mentioning these more and more, but I'm actually going to go to the side and I'm going to talk about this for a minute. So when you have a number and it has an exponent with it, so like the exponent's usually kind of to the upper right, that number has a name. This is called your base. So you're going to start hearing us call that your base. And then obviously that number that's there is your exponent. And so start getting familiar with that terminology, because that's going to come up quite a bit. Okay, and so the number that is your base, the number that's with the exponent, so I'll just write that down, your base, that's what the b is, that is actually going to be what's called your growth or your decay factor. So your growth or decay factor, and it's going to depend on whether it's growing or decaying. And so that number is going to, like if it was growing, it's going to tell you at what rate it's growing in a way. Okay, so it's going to tell you how fast it's growing, or if it's decaying, it's going to tell you how fast it's decaying. So growing means that it's getting bigger. Decaying means that it's going away, or it's decreasing in some way. Okay, and so when you're looking at an equation, all these numbers that you see have a lot of meaning to what's going on in the function. Okay, and so you would have learned in the other slide that we talked about, exponential functions are very much related to real life, and especially right now, they're very much related to what's going on right now. And so these are important to kind of know how they work, so that we can learn what's going on, okay, and kind of stay current with what is going on. Okay, so how do you know if it's a growth or a decay? Well, it's actually going to be based on this number. Okay, so if your factor, if this number is a certain set of numbers, it's going to make it grow. So think about what's going on here. You're taking a starting value. So let's say that it's, because an exponential equation example would be like population growth. So let's say that it started out with 3 people, and then it's doubling, the population is doubling every month. Well, then after 1 month, you started out with 3 people, so if it's doubling after 1 month, then that means there would be twice as many people. So 3 times 2, that would be 6 people. Then after another month after that, it would be 12 people. You're doubling, so you're multiplying by 2. So if this number right here, that's the number that you're multiplying by, if that number is bigger than 1, it's actually going to make it grow. So think about like all the numbers that are bigger than 1. If I multiply by 2, it's going to make it grow. If I multiply by 3 or 4 or even 1.5, it's still going to make it grow. Okay, so your growth, how do you know if an exponential function is growing? You are going to look at that number, and if it is greater than 1, so make sure that you remember that symbol means greater than. So if it's greater than 1, then it's going to make it grow. And the graph, these are the graphs that start out kind of low, and then they all of a sudden grow what's called exponentially. So it goes up really quickly, and it almost looks like it goes up vertically, but it's not exactly vertical, but it looks that way. So like it's going to kind of start out kind of flat looking, but then all of a sudden it's going to take a turn, and then it's going to almost look like it's going straight up. Okay, that is an exponential growth, because notice as we start out, it's kind of flat, but then all of a sudden it takes a turn and then it grows exponentially. Okay, so that's if your growth factor is a number that's bigger than 1. Okay, any number that's bigger than 1 is going to make it grow because you're multiplying by a number that's bigger than 1. Okay, well then what kind of number would that be to make it decay? In other words, go away. Well, think about what numbers you would multiply by that would make something decrease. That would actually be all your decimal numbers. And you got to be careful when you kind of think about decimals. It's actually the numbers that are between 0 and 1. So the way that you write that is it's going to be between this. So it's going to be bigger. So the b is going to be bigger than 0. Remember, alligator eats the bigger number. But then it has to be less than 1. So the way that you kind of read this is b, that growth factor, is going to be between 0 and 1. Okay, so think about all the numbers that are between 0 and 1, like 1/2. If there's a 1/2 right here, and it starts out with a certain number of people, and you multiply by 1/2 each time, well, that multiplying by 1/2 is essentially the same thing as dividing by 2. So that means you're kind of dividing it by 2 each time. So like if you started out with 8 people, 8 times 1/2, or 8 divided by 2 is 4. So after a month, it'd be 4 people. After another month, it'd be 2 people. After another month, it'd be 1 person. So you're dividing by 2. And so whenever the b is some number between 0 and 1, so all the decimals between 0 and 1, it's actually going to make it decay. So this graph would almost be the reverse of that one. So this one would start out kind of tall, or up here, and then it kind of decreases really dramatically and then levels off as it goes to the right. So it starts up, then it decreases really suddenly, and then it kind of levels off. So this would be the graph of a decay. Okay, so what we're going to do is just practice being given an equation and then kind of sketching the graph of it so you can get familiar with how the equation relates to the graph. Okay, so in these problems it says sketch a graph of the following exponential functions. All right, well, notice it's exponential because it has x in the exponent spot. So when I graph this one, so I'm going to draw my graph, there's a couple things I have to figure out first, all right, to be able to sketch it. So we're not being super specific right now. We're just sketching a picture. The first thing that I want to look for is what is my initial value? What is my y-intercept? And so that's going to be the number that's in front of the base that's with the x. So if I look at this equation, you can even write down y equals a times b to the x above it if you need to line it up. But the number that's in front of the one that's with the x is 2. So then my y-intercept in this problem would be 2. Okay, and then remember that's where it's going to cross the y-axis. So you would go to your y-axis to 2 and you would put a dot. Okay, then from there you have to figure out, well, what's happening? Is this going to be a growth or is it going to be a decay? And so that's where you look at your b. So if b is a number that's bigger than 1, then that means it's going to grow. So it's going to look like that. If it's a number that's between 0 and 1, then it's going to look the opposite. So it's going to start up and then go down. Okay, so my b in this problem is the number that's with the x. So that would be 2. And so you're going to ask yourself, so my b is equal to 2, is that number bigger than 1 or between 0 and 1? And 2 is definitely bigger than 1. So because of that, this would be a growth. That means that it's actually, because that's my growth factor, it's actually doubling every time. Okay, so that means the graph's going to look like this. And so when you sketch it, you're going to draw it so that it kind of starts out level. You need to make sure that it hits the y-axis at where the y-intercept's supposed to be, and then you're going to make it go up from there. So takes practice, but you've got kind of some level, and then it's going to kind of make a turn, and it's going to go up. It does not have to be perfect, but it does need to look like it's growing, and it does have to go through the y-axis. Okay, so that is the graph, or a sketch of the graph for that function. Okay, so we're going to do that a couple more times. So with number 2, sketch my graph here. I'm going to find my y-intercept. So remember the y-intercept is your a. So look for the number that's in front of the number with the x. So let's see, in this problem, the number that's in front is the 1. So that means your y-intercept would be 1. So I'm just going to draw a dot right there. And I'm going to draw a couple more little lines so we have a reference point. And then to know if it's a growth or a decay, you look for your b. So my b in this problem is 3 because that's the number with the x. And so is that number bigger than 1 or between 0 and 1? And it's also bigger than 1, so that means that this is a growth. And that number would be called your growth factor. So in this problem, if it was like a population, it started out with 1 person and it's tripling each time. Okay, so because it's a growth, it's going to look like this. So when I draw my graph, I'm going to start it out kind of level, and then I'm going to make sure it goes through the y-axis there, and then I'm going to make it take kind of a turn upwards. So that is a sketch of that graph. Okay, so let's do one more. This one, find my y-intercept, and then look at my b to know if it's a growth or a decay. So my y-intercept here, the number that's in front of the one that's with the x is 8. So that's where it's going to hit the y-axis. And then my b is 1/2. And so when I look at if it's a growth or a decay, well, 1/2 is not bigger than 1. It's actually between 0 and 1. So that means that this one is actually decay. And so what's happening in this problem is if it was like population, the population's being cut in half every time. And so that's going to look like that graph. Okay, so I'm going to go ahead and draw my y-intercepts. So we got 1, 2, 3, 4, 5, 6, 7, 8. So it's going to cross the y-axis right there. So my graph's going to look a little bit higher just because the y-intercept's there. And then I'm going to draw it so that it starts up. I'm going to make sure it goes through that point, and then I'm going to make it level off. So notice this goes the opposite way. So it starts up and then kind of levels off as I go that way. Okay, so there we go. So that's the basics of an exponential function and kind of how to sketch a graph.